So if you recall, we were conducting a hypothesis test to test a claim about a population mean. And in the previous examples, I always told you that the population standard deviation sigma was known. But in this case, I want to do in a slight variation where we do not know the population standard deviation sigma, and instead we have to use the sample standard deviation S as an estimate. So just to review the whole problem, in this example, according to a vendor, a 50-cent vending machine is supposed to dispense 14 grams of chocolate. A customer suspects the machine has been dispensing less chocolate lately. So he purchases chocolate at 31 randomly selected times and records the weight of the chocolate dispensed at each time. He then calculates the mean of the 31 weights to be X bar equal to 13 and 69 hundredths of gram, and the standard deviation to be S equal 907 thousandths of a gram. So that's a sample standard deviation. The population standard deviation, sigma, is unknown. Use a hypothesis test to test the claim that the mean amount of chocolate dispensed by the machine has decreased. So I'm just going to show you how you can do this in StatCrunch, because in this case you will need technology. There are tables that can help, but we're just going to be using technology in this case, since we will once we use the sample standard deviation, we can no longer use the normal distribution. We will need to use the student's t distribution. Okay, and then in order to calculate p-values, we really need, it's much easier to do using technology. So here I am in StatCrunch, and the commands are stat, tstats, one sample with summary, since I have, 13.69 grams is my sample mean, and I have 907 thousandths of a gram for my sample standard deviation. So I have my summary data. Okay, and the sample mean we said was 13.69. The sample standard deviation was 907 thousandths, and the sample size was 31. So the null hypothesis in this case was that mu is equal to 14 grams, and the alternative hypothesis was that that the mean weight is decreasing, so that mu is less than 14 grams. I don't need to fill out any of the other stuff, and I hit compute. Here's my readout. And you can see that the test statistic is the same exact test statistic that we got before. It's negative 1.90, or rounds to that. So you don't even, technology will also give you the test statistic. You don't have to calculate that. And the p-value that we get is 0.0333. And if you recall, this is greater than the p-value that we had when we used the normal distribution and we assumed sigma was known. That's just because in the t distribution, it's a bell-shaped curve, but there's fatter tail, so there's more variation, meaning that our p-values are going to be greater. So in this case, though, 0.0333 is still less than 0.05 or 5 hundredths. So in this case, we would still reject the null hypothesis, and there would still be sufficient evidence to support the claim that the mean weight of the dispensed candy is less than 14, or that it's grams, or that it is decreasing.